control.
Okay guys, so let's start solving our first problem. So this sample number 1 is under the topic of aerodynamic and rolling resistance. So we have a 2,500 pound car just driven at sea level with rho, which is equivalent to 0.002378 slug per cubic feet on a level paved surface. The car has a value of C sub D, which is equal to 0.38 and a frontal area of 220 feet squared. It is known that at maximum speed, 50 horsepower is being expended to overcome rolling and aerodynamic resistance. So we need to find or determine the car's maximum speed. Okay, so the solution for this is that it is known that at maximum speed or B sub M, we have an available equation of available horsepower, which is equals to R sub A multiplied by B sub M plus R sub RL multiplied by B sub M. Kung saan, di ba alam natin yung iyong equation for R sub A and yung R sub RL is given by this equation. So, substitute nyo lang. So, the available horsepower now is equals to rho over 2 multiplied by C sub D times A sub F multiplied by BM squared. So, kaya naging cube yan, kinuha niya lang yung isang B sub M or yung maximum speed. Okay, so, and then yung isa, yung R sub RL, so ang equation niyan is F sub RL multiplied by W. So, substitute nyo lang to form this equation. Okay, so from that, substitute the given value based dun sa problem natin. So substituting that, we will arrive at an equation of 50 horsepower is equals to the rho or 0.002378 so divided by 2 times C sub D or 0.38 times A sub F or yung ating frontal area na 20 feet squared times the BM cube or yung unknown na hinahanap. And then plus 0.01 times yung ating 1 plus B sub M over 147 multiply by 2,500 times B sub M all over 550. So, using your calculator, so shift solve nyo lang. So, we will arrive at an answer of 133 feet per second, or if you're going to convert this to miles per hour, so that is 90 miles per hour. Okay, so let's proceed with the next topic. So this time, we will now discuss the grade resistance. The grade resistance is simply the gravitational force or the component of parallel to the roadway acting on the vehicle. So as suggested sa ating figure 2.1, the expression for grade resistance is given by R sub G equals to W sine of theta G. As in the development of the rolling resistance formula, equation 2.6, highway grade are usually very small. The sine of theta G is equals to tangent theta G. As it approaches, almost equals na sila. Rewriting the equation, we get R sub G is equals to W tangent of theta sub G, or that is equals to W multiplied by G. Kung saan yung G natin, so that is defined as the grade, defined as the vertical rise per some specified horizontal distance opposite side of the force triangle in figure 2.1 divided by the adjacent side in feet per feet. The grades are generally specified as percentage for ease of understanding. Thus, a roadway that rises 5 feet vertically per 100 horizontal. So in every 100 feet na horizontal mo, meron kang rise na 5 feet. So ang grade niya, so ang gawin mo lang, 5 divided by 100 or 0.05. And yung theta g niya, if compute mo siya, so that the angle will be 2.86 degrees. And this is said to have a 5% grade. Okay? Yan lang yan. Para ma-compute mo yan, so yung 5% grade, so 5 divided by 100 times 100. Ano? Para makuha yung 5% grade. Okay, so para mas maunawaan to, yung grade resistance, mag-try tayo ng isang example. So, for sample number 2, under grade resistance, so we have a 2,000 pound car which has a C sub D of 0.4 and a frontal area of 20 feet squared. And an available tractive effort of 255 pound. If the car is traveling at an elevation of 5,000 feet, where ρ is given as 0.002045 slug per cubic feet, on a paved surface at a speed of 70 miles per hour. So what is the maximum grade that this car could ascend and still maintain the 70 miles per hour speed? Okay, so the solution for this is, so to maintain the speed, the available tractive effort will be exactly equal to the summation of resistance. Thus, no tractive effort will remain for vehicle acceleration, where that is equals to m times a is equals to 0. Therefore, equation 2.2 can be written as follow. So F is equals to R sub a plus R sub RL and plus RG. So for grade resistance, using equation 2.9, so again, yung RG mo is equals to W multiplied by G, or natin, or that is equals to 2,000 times G. And for aerodynamic resistance, we are going to use the equation 2.3. So given as R sub A is equals to rho over 2 times C sub D, A sub F, D squared. So again guys, as substitution lang siya, as long as meron kang malistahan ng yung equation na gagamitin, I think there's no problem in solving type of problem. 0.002045 over 2 times 0.4 times 20 times 70 528 divided by 3,600 squared. So the R sub A is also 86.22. And for rolling resistance, we are going to use the equation 2.2. So that is R sub RL plus sub RL multiplied by W. Or it can be written also, so diba ang iyong F sub RL has an equation of this, or 0.0001 multiplied by the quantity of 1 plus 70 times 5280 over 3,600 over 147. So yung mga 5280 mo, ito is i-convert niya lang yung miles into feet. Yung hours mo, kaya meron ang 3,600, convert niya into second. Okay, so the answer is 33.97. So since we have now the values of RA and R sub RL, and meron ka naman ng R sub G, we can now compute for the value of G. So given as yung F mo nga, so di ba yung F mo is the available tractive effort, which is 255. So with that, the value of G is equal to 0.0674. Or if you're going to get the percentage, so that is 6.74% grade. Okay, next topic natin is yung tinatawag nating available tractive effort. So ano ba yung available tractive effort? So the tractive effort available to overcome resistance and or to accelerate the vehicle is determined either by the force generated by the vehicle's engine or by some maximum value that will be a function of the vehicle's weight distribution and the characteristic of the roadway surface or tire interface. The basic concept underlying these two determinants of available tractive efforts are presented here. Okay, so for 2.6.1, the maximum tractive effort. So given no matter how much force a vehicle engines make available at the roadway surface, there is a point beyond which additional force merely result in the spinning of tires and does not overcome resistance or accelerate the vehicle. So nangyari parang dudulas ka lang ano. So given by this diagram, so vehicle forces and moment generating distances. Ito yung mga variables na gagamitin natin. So before, I think you're familiar already with these values here. So dagdag lang natin yung weight. W sub F mo is the weight of the vehicle of the frontal axle pound. So before, di ba W lang yung ino natin. Now, we need to consider also weight of the vehicle on the front axle. So that is denoted by W sub F. And if W sub R, that is the weight of the vehicle on the rear axle. Okay, so ito namang iba dito, familiar na kayo. So ano lang natin tong H. Itong L. So this is the length of the wheelbase. So ito po diagram. So that is center to center ng dalawang wheels. And H is the height of the center of gravity above the roadway surface. So from the surface of the road up to the center of gravity ng iyong vehicle. L sub F, so this is the distance from the front axle to the center of gravity. So ito lang po siya, yung front axle mo nandun sa center of gravity. Okay, so yung center of gravity, again natin, is kung yung point kung saan nakatutok yung iyong weight W. And yung L sub R mo is the distance from the rear axle to the center of gravity. Okay? So, next slide. So, these are the equations that we are going to use. So, we have 2.10, 2.11, and 2.12. So, to determine the maximum tractive effort that the roadway surface tire contact can support, it is necessary to examine the normal loads on the axles. So the normal load on the rear axle or yung W sub R mo is given by summing the moments about 0.8. And we should see the figure 2. So anong ginawa? Sabi daw magmo-moment lang tayo doon sa point A. Point 2. 2.2 yung tinitingnan natin. So, where is your point A here? Itong front axle. So, magmo-moment ka lang daw dito. And then, yung mga force na yun, ito yung magiging equation mo. So, W sub R is equals to RA multiplied by H plus W L sub F cosine of theta sub G plus mass AH and then plus or minus WH sine of theta G. So, on the next statement, i-discuss kung kailan siya positive or negative. And then over L, or yung moment arm ni W sub R. So, in this equation, the grade moment, W sub H sine theta sub G is positive for an upward slope. So, positive yung value niya kapag pataas yung slope. And negative for a downward slope o pagpa-descend yung karsada. So, rearranging the term, assuming that cosine of theta G is equals to 1 for the very small grades encountered in highway application, and substituting into equation 2.2 gives the equation of 1. So, yung W sub R mo is equals to L sub F multiplied by W over L plus H over L multiplied by F minus R sub R L. For basic physics, the maximum tractive effort as determined by the roadway surface tire interaction will be the normal force multiplied by the coefficient of road adhesion. So, for a rear-wheel drive car, the maximum force F equals to mu times W sub R. Okay? Or yung mu sub N. So, ito is yung principle ng friction. So, ito lang din yung concept niya. So let's proceed with the next slide. So additional formulas. So this time for maximum tractive effort again, 2.6.1, and substituting equation 2.11 into equation 2.12. So we will arrive at this equation na F sub max is equals to mu, quantity of L sub F times W over L plus H over L times F sub max minus R sub R L. So, kapag i-distribute mo lang yan, so ganito yung magiging equation mo, or in a simplest form, so F sub max is equals to mu times W, quantity of L sub F minus F sub RL times H L over 1 minus mu sub H over L. So same lang din yung equation na yan. Ano lang to? Ito lang yung ginawa niya lang to para mas madaling matanda. So gano'n, pinulsaman yan. So either of these two naman, pwede nyo naman gamitin. Ano? So similarly, by summing moments about point B, so this time, doon naman tayo sa point B. If figure 2.2, it can be shown that for a front-wheel drive vehicle, so kapag front-wheel drive siya, so yung Fmax mo is given an equation of Fmax is equals to mu times W, quantity of L sub R plus F sub RL times H over L over 1 plus mu over L. So, as you can see here, halos pareho lang naman yung equation niya. So, tandaan na lang, yung L sub F mo, mapapalitan ng L sub R. Okay? Then, yung negative sign, gawin mo lang siyang positive. So, this is applicable for a front-wheel drive vehicle. Itong equation 2.15. Okay. So note that equation 2.4 and 2.15, because of cancelling of units H, L sub F, L sub R, and L can be a unit of length. So it's either feet, inches, etc. However, all of these terms must be in the same chosen unit of measure. So the units of Fmax will be the same as for W, pound. Okay, so for maximum tractive efforts, so you have this problem. Sample number 3. So this is your solution. Hindi ko na pala nagawa ng animations. Anyway, so we have a 2,500 pound car designed with a 120-inch wheelbase. So the center of gravity is located 22 inches above the pavement and 40 inches behind the front axles. So if the coefficient of road adhesion is 0.6, so what is the maximum tractive effort then that can be developed if the car is A, if it's front-wheel drive, and B, if rear-wheel drive. So for the front-wheel drive case, equation 2.15 is used. So we have Fmax is mu times W, quantity of L sub R plus F sub RL times H over L plus 1 over 1 plus mu H over L. So, and for equation 2.5, we know that F sub RL is equal to 0.01. And because the velocity is equal to 0 feet per second, so the equation will be equals to yung F sub max mo for the front wheel drive. So, 0.6, 1,500 times the quantity of 8 plus 0.01, 22, over 120 over 1 plus 0.6 over 1. So, yung Fmax mo or the maximum tractive effort then can develop in a wheel drive is 903.38. And for the rear wheel drive case, we will use the equation 2.14. Or the equation will be F sub max equals to 0.6 times 2,500, quantity of 40 minus 0.01 times 22 over 120, 1 over 1 minus 0.6 times 22 over 1. Yung Fmax mo, if rear-wheel drive ka, is 550.71. So as you can see here, yung maximum tractive effort for a rear-wheel drive is much lesser compared dun sa vehicle na naka-front-wheel drive which has a value of 0.38. Okay, so putulin muna natin dito.